in the back, I think. Okay, listen, boys and girls, we're getting started. So today we're talking about rational exponents, and we talked about exponents at the beginning of the year because that's also an 8th grade standard. This just goes a little deeper, gets a little more difficult than what they learn in 8th grade. But at the end of the year, when you take the 8th grade math test, you're going to see exponents. That's going to be on there because that's an 8th grade standard. So on example 1, it says you can think of an exponential as a repeated multiplication. So when it says 3 to the 3rd power, that's the same thing as taking 3 times 3 times 3. So it's just repeated multiplication. So 3 to the 4th power would be 3 times 3 times 3 times 3 because there's going to be 4 of them multiplied. So 3 to the 5th power would be 3 times 3 times 3 times 3 times 3. That's the 8th grade standard. You have to know what exponents mean. You have to know that they mean repeated multiplication. But in Algebra 1, we start talking about what happens if you have a fraction as your exponent. So it says, what about 3 to the 1/2 power? Okay. So I'm just going to show you really quick. 3 to the 1/2 power is the square root of 3. So both numbers of your fraction are important. They tell you something about what you're going to be doing. The bottom number tells you if it's a 2, it's going to be a square root. If it's a 3, it's going to be a little cubed root. If it's a 4, it's going to be the square root with a little 4 in here. And then the 1 tells you the exponent of the number. So this would be like 3 to the 1st power. But you don't actually have to say 3 to the 1st power because 3 to the 1st power is just 3. So when you see 3 to the 1/2 power, it is just the square root of 3. And you have a calculator on your desk most likely. If you take the square root of 3, and I'll show you how to type it in, the square root button, you have to hit this blue second button right here at the top, and then there's a button that says x squared right by the 7. It's a square root button. Looks like a division sign with a little check mark, and you want to type in 3. So it's like 1.73 whatever, big decimal. So that's how you would take a square root if you needed to. Second, x squared, and then type in whatever square root you're wanting to do. So I just wanted to show you that because on the math test at the end of the year, you get to use your calculator the entire time, I believe. So on the next one, it says try these. Then it says 2 to the 1/2 power. So you're going to start, if the bottom number is a 2, you know you're going to have a square root sign. You're going to have the big number that it starts with, that goes underneath the square root sign. So it's like saying this top number in your fraction is the exponent of the larger number. Okay, switch mask breaks. And the bottom number is telling you what you're doing. Like if it's a 2, that means you're taking the square root. And you'll see what I'm saying in just a second. I need to make my marker smaller. It's bothering me. There we go. This next one says 8 to the 1/5 power. So I always am going to start with this little square root. The big number goes under the radical. That's what that's called. The top number is the exponent for the larger number. So it's like 8 to the 1st power. And then the bottom number goes right here in that little check mark part. So that's not taking the square root. You're taking, it's like, I don't even know how to say that. I'll have to look back into it. It's been so long since I've done this. But the top, it's like the same thing every single time. So the third one, make a square root sign. The big number goes under the radical. The top number is the exponent for the larger number. And the bottom number is the thing that goes right in this check mark part. We know what 3 to the 3rd power is, so you could type this stuff into your calculator if you wanted to, but right now they don't want you to do that. They just want to know what it is simplified. So here are the rules. How does the exponent affect the root? So the denominator, that looks kind of like a C and an L, not a D. Denominator, which is the bottom number of your fraction, is the root number. So if it's a 2, you're taking the square root. If it's a 3, you're taking the cubed root. So these are like the generic rules right here. This one says A, and then the numerator is a 1, the denominator is an N. So you're going to start with your square root sign. The first thing you're putting is this number right here underneath the square root sign. This is just an A. So I'm going to put an A underneath the square root. The denominator is your root. That's going to go in the little check mark part. And then the top number is the exponent for your larger number. Same exact thing here. I'm starting with a square root. The first number that you see that goes under your radical. The denominator is your little root right here. And then the top number or the numerator is the exponent. So now we are going to work backwards, and I'm going to write these rules down at the top of our paper because they're going to help you out. So if you want to do that, you can, but these two things are interchangeable. So I'm going to write down the example up here. So A to the 1 over n power is the same thing as the square root of A to the first power, and then you take the nth root of that. Those two things are interchangeable. They mean the exact same thing. So now, when they give you the other way, you have to figure out the part with the fraction. So on the first one, it does not give you a number in that little check mark part. If they don't give you a number, that means there's a 2 there. That means you're taking the square root. Okay, masks back on. So now I know there's a little 2 in that first check mark. So what we'll want to do is you find the number that's underneath the radical. It's an x. The number that is attached to that, or the exponent, goes on the top. And then the root goes on the bottom, which in this case is a 2. I know that's super tiny. Hopefully you can see that. So if you look at the one right below that, 5 does not have an exponent. So what would that make the exponent? A 1. So you can put that little 1 right there just so you know you need to use that. So I know I'm going to start with a 5 because that was underneath the radical. The exponent goes on the top, which you just told me that was a 1, and then I think that's a 3, right? Okay. And the last one, the number that's underneath the radical is a 3. The exponent for that was a 2, and the root was also a 3. It was a cubed root. So they're just showing you how to change from one way to the other way. They mean the exact same thing, but there are certain situations which will make this easier for you to solve things. So they just want to make sure you know what ways you can write these down. Okay, I don't know if I did. So this is where you actually get some problems to solve. And this is where you're going to have to use the exponent rules we learned at the very beginning of the year. This is why we didn't go straight into algebra, because you have to know those exponent rules to do these problems. When you're multiplying with your exponents, that means you're adding them up. So do you see how the base for the first one is a 3, the base for the second one is a 3, and the base for the third one is a 3? Since the base is all the same, we can drop it. Last year I said drop the base, and everybody told me I cannot say that anymore, but you drop the base and you're left with your exponents. So when you multiply exponents, you add them up. So the first one is 2x, and I'm trying to multiply it to this one, so I'm going to add that exponent to it. and it says it equals, what's the exponent for this last one? 7. So now this is just a two-step equation, and I can figure out what x is by doing that. So I'm going to draw my line. If you like doing that, you can. The opposite of positive 3 is negative 3. That's not a good 3. Okay, and then I have 2x equals 4. When I divide by 2, I get that x equals 2. So even though the x was an exponent, we are still able to figure it out by knowing our exponent rules and by knowing if I have the same base every single time, this one's a 3, 3, and a 3, I can drop that and just work with the exponents. All right, same thing on B. So what you notice is you have a base of 2, a base of 2, and a base of 2. So now that I know I have the same base for all 3 numbers, they all have to be the same in order to do this, I'm going to drop the base, and I'm going to write my exponent. So the first one is a 4. I'm trying to multiply it to the next one, and when you multiply exponents, you're adding them up, and it should equal 10. So now we're going to solve this two-step equation, and that will tell us what x equals. So I don't want to move the 2x first. I want to move this positive 4. So I'm going to subtract 4 first. I've got 2x equals 6. I'm going to divide by 2 on both sides, and I'm left with x equals 3. Okay. Moving on. It says simplify these expressions. So this is power to power. That means if you have something that has an exponent and you want to take it to another exponent, you multiply. So on the first one, all you have to do is multiply 3, my exponents times each other, 3 times 2. So what is 3 times 2? 6. So that's 2 to the 6th power. You can figure that out in your calculator. If it says to evaluate, they want to know an actual number. So if you don't remember how to use your calculator, I'm going to show you really quick. You can type these directly into your calculator. So you type in the base first, which is 2, the caret button, and then the exponent after. So 2 to the 6th power is 64. Remember, that is also, you're taking 2 times itself 6 times. So you could also just do that and type it in, but that would take a little bit longer. Okay, so that was number 1. Number 2, I wish I could make this bigger. Oh, didn't even see it. There you go. I still wish I could make it bigger, but that's okay. Okay, so really quickly on this one, we have 2 plus 3 squared, and then we want to square that whole thing. Well, we know what 3 squared is. So instead of saying 2 plus 3 squared, we could also say 2 plus, and what is 3 squared? 9. 3 times 3 is 9, and then we're going to square it. There's a couple ways you can do this. You can give the 2 to both numbers, or you can add the parentheses up first. So what is 2 plus 9? And then you can square that, which ends up giving you 121. The other way you could have done that is you could have taken 2 squared, which is 4, and 9 squared, which is 81, but that doesn't seem... Oh, you have to add them up first and then square it, I guess. I don't know. Okay, this is the first one that has a radical in it. So we haven't done one like this yet. What we're going to want to do is we want to just look at the inside first. So it has a square root, I believe. Is that a 2? It's so tiny. Here it is. This is a 3 to the 2nd power. And then if it doesn't have anything over the check mark, you put a 2 there as well. So what we want to do is we actually want to write this as a fraction. The first big number of our fraction is going to be the 3, and then it's going to be 2 over 2. The numerator and the denominator are both 2. And what does 2 over 2 simplify to? 3 to the first power. And then we want to square that. So what I did is I just changed the inside number a little bit to make it easier for us. 3 to the first power is just 3, correct? So what is 3 squared? That's our answer. So the whole purpose of that one is if I know that I can change this to a fraction, then I can get the actual answer. Okay. Try this one. So what you want to do, and this would be a case where you'd want to drop the base. I'm going to write this bigger because I don't know that you can see this very well. You don't need to do this. I'm just doing this so you can see. All right, so this is what we have on the try this problem. The only way you can drop the base and just set the two exponents equal to each other is if the base is the same. Well, this one is a 27 and this one is a 3. Are those the same number? So you want to make them the same number, which luckily we know that 27, how do I get 27 with 3's? 3 times 3 times 3. 3 times 3 is 9, and then 9 times 3 is what? So instead of writing 27, we're going to write that as 3 to the third power. And then we're going to have the exponent is exactly the same, x minus 4. And we're keeping this guy exactly the same for right now until we figure out what to do with that other side. Only thing that's changed is the 27 changed to 3 to the third power. Those two things mean the same thing, but one of them has a base of 3, which is what we want. So we have to simplify this left side a little bit. We need to take 3 times x and 3 times negative 4 so that we have an exponent that is simplified. So what is 3 times x? Sorry, what is 3 times negative 4? And then the other side stays exactly the way it was. We don't have to do anything with that because it already had a base of 3. Now, this one has a base of 3. This one has a base of 3. I can drop that and just use my exponents. So 3x minus 12 equals 2x minus 6. And now we can solve for x. So I'm going to draw my line here. By the way, once you get to this point, this is an 8th grade standard. So solving an equation like this will be on your math test at the end of the year. So you want to move your x's together first. Right now I have 3 x's on the left and 2 x's on the right. Those need to be on the same side. So I'm going to move this one over. 2x minus 2x is 0. I don't need to say that, but 3x minus 2x is 1x, or you could just put x. Minus 12 equals negative 6. To get x by itself, we're going to add 12 to the negative 6. So what is negative 6 plus 12? 6. So now we know that x equals 6, and you're done with that one. We have one more question. I even put that one on there. Okay, this is the application problem. We're just going to start reading and talking about it. Hey, guys. No, this is not just a Gannon thing. There's people who've been talking in the back all day, and I'm trying to teach you. And then I hear people saying, I can't see, I don't understand. Stop talking. Then you might understand. Adam is setting up for an outdoor concert. He places 3 square blankets near the band as shown in the picture. What is the area of blanket C? So like they said, he places 3 blankets, blanket A, blanket B, and blanket C. on the grassy area at a concert. So what they're wanting to do is they want us to know what the area of blanket C is, and it tells us that it's X yards squared. And then they tell us that, I don't know what the 12 yard is saying. Hold on 1 second. I'm trying to decide if the 12 yard. Yeah, so yeah, that's what the area is. Okay, so it says area equals, this is already on yours, but I didn't put the copy of it on here. So the area equals length times width. The area of the thing is 12 yards squared. That's not an equal sign. There we go. Okay, so the area is 12. The length, we're trying to find the area of, I have 8 to the power of 1 over 2 times x to the power of 1 over 2. So I'm using the blanket B and I'm using the blanket C, and I'm trying to find the area of the entire thing. So when you have 1/2, both of them have 1/2, you can put these together. So since this one has a 1/2 and this one has a 1/2, you can actually just combine the 8 and the x and then give them both the 1/2. And then we can rewrite it. So instead of writing 1/2, this would be the same thing as saying the square root of 8x. Does anyone know how to undo a square root? What's the opposite of the square root? Square. So we're going to square this side to get rid of the square root, and we're going to square this side to get, if you do it to the right side, you have to do it to the left side. What is 12 squared? Okay, and then the purpose of taking this side and squaring it is now the square root goes away, so we're just left with 8x. So to solve this, all I have to do is divide by 8. So if you have a calculator, take 144 divided by 8. That's what x equals. So blanket C is 18 yards squared. All right, we're not going to do anything else today. Like I told you before, if you're not done with your test corrections, you need to be giving those back to me by Wednesday at 3. Whenever you finish them, just put them in the tray.